This is going to cover page 29, numbers 13, 19, 26, 27, 29, 32, and 35. Number 13 starts asking us to use the distributive property to rewrite each expression, then to evaluate. Number 13 is this problem. First of all, like the instruction says, we have to distribute. So let me just underline, make that red to make sure you understand the distributive property. From our understanding of the distributive property, we have to distribute the 6 into each one of these terms. There are 2 terms. So the 6 needs to be distributed to the 4. Looks like this after it's distributed. Plus 6 has to be distributed into the 5. Looks like that. That is called the distributive property. That is when you distribute the 6 into each one of these terms. You should have something looking like this for the distributive property. Next, we can make some substitution. 6 times 4 is 24. Let me make that green for you. 24 is your green. Next, 6 times 5. I can make that blue for you. That becomes 30. Together, you add this up before we move on. That is your substitution step. Together, they make 54, and that is by substitution. Okay. Number 19 gives us this problem. 19 looks like number 13, but this time there is negative. Again, we use the distributive property to rewrite each expression, then we evaluate. So we first have to do the distributive property. Nothing has changed. The 4 is going to be multiplied to the 7. So it's going to look like this. 4 times the 7. Okay. Then the subtraction sign right here. Then 4 is going to multiply into that 2. That is called the distributive property. Okay. Now you combine each one of the terms. 4 times 7 is 28. I can show that here. 4 times 7, this becomes 28. 4 times 2 is 8. Okay. And we call that the substitution step. Making one more substitution, 28 minus 8, that becomes 20. And that is also by the method of substitution. Okay. Number 26. Okay. Number 26 asks us to use the distributive property like before to rewrite each expression. But this time, they want to ask, then simplify. Okay. Number 26 looks like this. Okay. From here, what we need to do is, again, we have to distribute. So the 3 will need to multiply into the 5. So 3 multiplies into the 5 plus 3 will need to be multiplied to the n. See how I distribute the 3 times the 5, then 3 times n becomes 3n. Okay? Now I can simplify. 3 times 5 becomes 15. 3 times n, we can leave that as 3n. This is substitution. And this is as simplified as I can get. The reason why I cannot combine further is because 15 is your constant term and 3n is your variable term. You cannot combine a variable term and a constant term. After 26, we have number 27. Okay. Number 27 looks like number 26, but there is a negative. Does that change anything? No. Okay. We still follow the same instructions of using the distributive property to rewrite each expression, then simplify it. So again, let's do this. Okay, 8 will need to be distributed into the 4. Then 8 will need to be distributed to the 3m. Okay. Okay. Now you can multiply. Okay. 8 times 4 is 32. 8 times 3m is 24m. So it should look something like this. Okay. Because 8 times 4, I can make that blue for you. Becomes that number. 8 times 3m, I can make that orange. And you can see that becomes that. Okay. Good. Okay. This step is called the distribution step. And this is called the substitution because 8 times 4 becomes 32. 8 times 3m becomes 24m. Okay. 29 asks us simplify each expression. If not possible, just write simplified. Okay. So this one is going to be number 29. Okay. 29 gives us 3r plus 5r. These are both variable terms, and they have the same variable of r. So right here, what we can do is we can combine the two. We combine the two like terms. Okay. 13r plus 15r becomes 18r. Okay. It does not become 18r squared. No, right? 13r plus 5r just becomes 18r. They keep the same constant. They keep the same variable of r. After 29, we go to 32. Okay. 32, same thing. 32 is asking us simplify if each expression. If not possible, just write simplify. Okay. I have a 5z squared plus 3z plus 8z squared. Okay. What I'm going to do is I'm going to rearrange, and when I rearrange things, we call that the what property? We call that the commutative property, okay? Because I rearrange it. The reason why I rearrange it is because these two look very familiar, okay? Because this is z squared and this is also z squared, okay? So what I'm going to do is I'm going to apply the associate property by grouping them together, okay? Okay. Then I am going to add them. 5z squared plus 8z squared becomes 13z squared. Okay, this comes from combining these two terms. Then, anything happen to the 3z? No, so you can leave the 13z, 3z the way it is. Okay, so the answer should look like this. Okay, and that is substitution. Good. Okay. 35 looks like it behaves the same way. Okay, what I'm going to do is I'm going to apply the commutative property of addition and rearrange it. Okay. So let's see. I rearranged it. Do you see how I move the 4m? The 4m used to be right here. But now I move the 4m right here, right? When I move the order, I call that the commutative property. The reason I do that is so I can combine these three things. Let me show you. I'm going to apply the associative property of addition. Okay. Do you see? I can combine the 7m with the 2m and the 4m. Alright. Let me just make that blue for you. Together, they make 13m. Anything happen to the plus 5p? Nope. So you can leave it as plus 5p. And we call that the substitution. Okay? So this covers all the homework solutions.